Okay.
Okay, excellent. So let's get underway. So as promised, the title of this talk is Why You Should Upgrade Your Java and Containers Right Now. Ben Evans, I currently work for New Relic, and because I work for New Relic and it's a public company, I have to show you this slide. Now, probably a few of you know what this slide is. It's just a slide which says, because we're a public company, anything which we say which is forward-looking should not be taken as anything which you should make investment or purchasing decisions upon. Sure, loads of people were going to planning to go out and rush out and buy stocks and shares based on my talk today. So I think everything on these next two slides, I think Nelsie's already done a fantastic job of covering. So I shall just skip through them. The only point I'm going to make is that before I lived in the wonderful sunny Barcelona, I actually lived in London. And while I was there, I helped to run the London Java community. And while we were there, there was a project called Adopt OpenJDK that I helped to found with Martin Verberg and a few other people. And that's important. I'm going to come back and talk about that in a bit. So I just wanted to pick that point out of this intro slide. All right, so what are we going to talk about today? Well, we're going to talk about a bunch of things, really. I'm going to talk about how we got here and what the sort of current state of play of Java is. I'm actually going to show you quite a bit of data. And in order to understand what that data is, I do need to explain a little tiny bit about New Relic. Just to, it's not a sales pitch. It's just to show you where the data in the third section actually comes from, because it's a bit different to a lot of the other data that's out there in the marketplace. Lots of times you see surveys and people talking about things which come from people directly talking about or self-reporting their own data, if you like. And our data is different for reasons which will become very clear in about 10 minutes time. Then we're going to move on to talking about from the current state of Java. We're going to talk about why, the real heart of the talk is why is 11 so much better than 8 when you're talking about containerization and containerized applications. And then depending on how that section goes, and I should also say that if you have a question at any time, please do just ask. Again, I can't necessarily see you, so rather than using the hands up, just try to break in where you can and ask the questions as we're going along. Some of the data is probably would help from a bit of discussion, or I'm not saying it's going to be controversial, but I think there might be a few questions and a few things that people want to talk about. So especially in that third section, please ask if you have questions. So then after the containers section, we're going to talk about Java Flight Recorder, JFR, which is something which I've been working with a lot over the last 18 months. It is one of the key reasons why Java 11 is better in containers. And it has the advantage that because it's such a big subject, we can talk about it more or less depending on how much discussion, how many questions there have been up to that point. Okay, so let's get started. So 4 things to talk about. First of all, I know developers don't really like talking about things like release and support model and so forth, but it is actually quite important to understand how things have changed, because the world of Java and its releases is still a subject that a lot of people find confusing. Whenever I talk to developers and hang out with people, lots of people are still not absolutely clear on how Java is produced and released. And it does matter in terms of things like containerization and planning, your Java upgrades and things like that. So I do want to talk about it a little bit, and I also want to talk about Java 8, OpenJDK 8 and 11. So let's start at the beginning. I always kind of like to do a quick context setting, if you like, slide or two, and it really only is a slide or two. This is the shortest history, a brief history of Java, the briefest one you've ever seen. So here you go. Sun released Java in beta, 1995. A little known scripting language from Netscape, which is called LiveScript, decides to change its name to JavaScript purely for marketing reasons. So if you've ever wondered why JavaScript and Java have such similar names, yet they're completely different as languages and don't seem to have anything to do with each other, the answer is they don't have anything to do with each other, and it was just a marketing decision made 26 years ago. That's the only reason why they have the same name. Okay. All right. So now I'm going to jump forward 11 years to 2006, jumping over Java 3, Java 4, Java 5 to bring us to 2006. And Sun finally get around to open sourcing Java. right from the very beginning, some components of Java were open source, but not everything. So you couldn't actually build from start to finish a completely open source Java. Instead, it was just kind of sort of open source. In 2006, Sun made the decision, we're going to completely open source Java. But it's important to know that at the time they did this, the Java 6 was already out. So Java 6 never had a completely identical open source build. Instead, what happened next was that Sun ran out of money. So Oracle acquired Sun in 2010. Java 7 is still not out at this point. And so Oracle, one of the first things they do is to produce Java 7 as the first release based completely on open source code. So from Java 7 onwards, even when you're running the Oracle JDK, it's really based on OpenJDK. And that's one of the things that people don't always understand. Because sometimes people get confused about what's the difference between Oracle JDK and OpenJDK. Well, from Java 7 onwards, they're basically the same product. Now, if we bring ourselves all the way pretty much up to the future, Java 8. Everybody loves Java 8. It's got Lambda expressions. What's not to like about Java 8? Everybody loves it. And so much so that it's now 7 years old. Doesn't feel like it. It still feels like a fresh release in many ways. And it's just a comfortable, really, really good environment everyone's really used to, and everyone knows how Java 8 works. Java 9 shows up 3 years later, and it's the last Java release in this kind. Because if you look sort of carefully, you can see that Java 7 comes out in, well, 2011. 2006, so it's kind of 3-4 years between releases, 2011, 2014, and then Java 9 in 2017. And this is the way that enterprises are used to consuming Java. That every 3 years, there'll be a big release, and people will say, oh, it's time to upgrade from Java 7 to Java 8. And then there's a big enterprise project within your organization to migrate hundreds or thousands of VMs from one major release to another. So this is what we sometimes call the capstone release, because it has like a big feature. You know, in Java 8, the big feature is Lambdas. In Java 9, the big feature is modules. So people are used to taking these big upgrade steps and doing a complete retest of their applications to upgrade Java. Java 9 actually changes that model quite a lot. And instead, it produces this new release model in which there are what are called long-term support releases. And if you notice, Java 8 and Java 11 are called out as long-term support releases. Java 9 is not, though. Java 9 is the first release. So although it was produced through this 3-year release cycle process, it's actually the first release in a new way of releasing Java. And it's not long-term support. Okay, that sounds weird. So let's talk about the new release model. In the new release model, there are 2 types of release. There is what Oracle call a feature release, and they come out every 6 months. And then there's also what's called a long-term support release. A long-term support release comes out once every 3 years. So you have Java 8, which obviously existed before this idea of a long-term support release, but hey, everyone loves Java 8. So they kind of retrospectively made Java 8 a long-term support release. And then there's Java 11, which is the current long-term support release, and it's what we're mostly going to talk about today. This September, we expect that Java 17, the plan is, and Oracle hate changing their roadmaps. So I'm pretty confident that Java 17 will also be declared a long-term support release in September when it arrives. Those are the only long-term support releases. Currently 8 and 11, and soon to be 17 as well. All of the other releases only live for 6 months. So Java 9 comes out, 6 months later, Java 10 comes out. Java 9 is dead. Java 10 comes out, lives for 6 months. Java 11 comes out, Java 10 is dead. Java 11 is special because it's long-term support release. But if you move up to Java 12, well, after 6 months, Java 13 comes out, and then Java 12 is dead. So you have this constant cadence every 6 months of releases which come out, feature releases. They live, they're supported for 6 months, and then they're gone. You cannot buy support from Oracle for a long-term, for anything other than a long-term support release. You go to Oracle and say, hey, I would like you to support Java 14 for me, and here is a big bag of money. They will say, thank you very much, we're not taking your money. And that's a strange thing, because there aren't many things about which Oracle will say, yeah, we're not going to take your money. So that gives you some idea of how seriously this is treated. Okay, so what does this mean? I've talked here a little bit about paid support. So, okay, paid support, you can get it from Oracle. They will only support LTS. If you don't like Oracle's prices, you can go to another vendor, as all systems will sell you support. Various other companies will as well. Okay, you might say, well, Ben, I've never paid for Java in my life. I don't feel like starting now. I'm like, well, you're not the only person that thinks like that. And in fact, if you want free updates, you have two choices. You can either continue to get free in the sense of doesn't cost anything. I really dislike in English the fact that we have this overloaded word free to both mean freedom and something which doesn't cost anything. In other languages, in French, those words are different. And in German, those words are different. But in English, unfortunately, we have this collision. When I say free here, I mean doesn't cost anything. So zero cost update, you can still get those from Oracle, and you can use them, and it's fine. But you have to upgrade every 6 months, because there are no more security patches coming for Java 14 from anyone. So if you want to stay security patched, and you want to continue getting your Java from Oracle, you must upgrade every 6 months. That also applies to the LTS versions. You can't get a Java 11 update from Oracle without paying for it. So if you want to stay security patched and you don't want to pay any money for it, your remaining option is to actually go to an alternative non-Oracle vendor. What I'm referring to here is an OpenJDK vendor, although of course Oracle is building on top of OpenJDK. So arguably the term OpenJDK vendor is a little misleading. It means another company other than Oracle. And overwhelmingly, that's what the Java market has done, as we'll see. And so what the end result is that Oracle's Java market share, as you'll see, is diminishing. So more and more people are moving away from Oracle as their Java provider and moving to another vendor, because they don't want to pay for it, and yet they want to continue to receive security updates. So what do we, when I say a new vendor, who are we talking about here? And some of these are not exactly new vendors, okay? It's folks like this. The one at the top, Eclipse Adoptium, is the new home for Adopt OpenJDK. So if people are running Adopt OpenJDK, very soon you will be getting your binaries from Eclipse Adoptium, which is the same community-led packaging and building and distribution project. Doesn't really do much in the way of source code work. So there aren't many patches or changes going into OpenJDK from Eclipse Adoptium. Instead, it's downstream. So, and I'm using the term downstream here. So you can kind of think of these as sort of like Linux distributions. There is an upstream Linux project, and there is an upstream OpenJDK project. And then downstream of that, there are various companies and various projects that package Linux or package OpenJDK for you. So we have Adoptium, we have Amazon Corretto. And this one's kind of interesting because the logo for Corretto is Duke, the little Java character, and he's handing out free ice cream. Now, I don't know if anyone speaks Italian, but a Corretto is not a type of ice cream. What a Corretto actually is a double espresso with a shot of grappa on the side. It's very nice, but it's perhaps not family friendly, which is why I think they went with this ice cream cart logo instead. So Amazon have this version which is tuned to run, and they do make some changes. They have a lot of data about what runs on AWS, so that their team actually does produce a lot of changes which go into their distribution of Corretto and upstream where appropriate. So it's quite nicely tuned for AWS. Microsoft have recently entered the fray and started producing their own build of OpenJDK. And that, of course, is firstly designed for Azure, but also both Amazon and Microsoft are engaged in what you might think of as trying to make sure that there are binaries which have clear provenance and what's sometimes called chain of custody in the corporate world. And that's all about making sure that when something like SolarWinds happens, you can be sure, what components were okay and what components you can trace backwards from. And that's becoming something which a lot of corporations are looking at closely. There's Red Hat. Red Hat were actually the first people ever to make, other than Oracle, to make a certified JDK. So they're still in the mix there. We've mentioned Azure Systems. They have the Zulu project, which is sort of semi-open and semi-commercial, but can be a great option if you don't mind paying for support. And then we also have people like Alibaba, who produce their own Dragonwell JDK, which has some advanced features in it and is kind of a bit experimental in some ways, but they're very keen and they're producing some really good stuff. And then IBM, of course. So what this all means is we now have this kind of mainline model. OpenJDK has features which only get merged when they're complete. The releases are happening once every 6 months, so they are on a strict time cadence. If you're late, you miss the boat. If your new feature or your bug fix or your patch for the JDK is not ready on time, the JDK release will not be held up for you. And because you can only merge when your code complete, that gives you an indication of how close you have to be to actually ready to release when the deadline comes. But when the deadline comes, the shutters come down and your patch will be shipping in 6 months' time, and that's it. Now, something which not everybody always realizes is this time-based release and only merge on complete has a pretty important consequence, which is that trunk or mainline is always releasable. So if you have to do an emergency fix of the JDK, you can do one straight away, because at any point you can merge an emergency patch fix and push it out, because no other patches will have been allowed to be merged. So that is basically the point of the new model for Mainline Dev. And yeah, there are these other longer term projects that you've probably heard of. You've probably heard of Loom and Valhalla. You might have heard of Project Amber as well. These are research directions for the language and for the JVM. And they're quite, they're kind of multiple year projects. So you don't want to do that in a branch. You do that in a complete clone of the repo, and it can actually run for as long as it needs to. Okay, so that's just a useful thing about how the JDK is developed. 8 and 11 are now run by the community directly. So Red Hat, Microsoft, other people are now running these projects. Oracle do not contribute directly to 8 and 11 anymore. They're still producing security patches, and the same patches do appear in OpenJDK. So the standard thing is when Oracle is ready to release a new version of their proprietary Java 8 and their proprietary Java 11, which you can still get, you just have to pay for. When they release those versions, the patches will automatically appear in OpenJDK as well. So when OpenJDK then releases, so I think there's a period of about 2 or 3 days where the Oracle patches are out, but OpenJDK is not yet. But it really is only a period of a few days. And the version numbers which come out are designed to be identical to the Oracle version numbers, which is just a way of giving certainty to enterprises that they're running the latest patch version. Adoptium has committed to supporting Java 8 until at least 2023. I am not a gambling man, having worked in the gambling industry when I was a lot younger. So I don't bet on things particularly. But if I was going to, I think I would bet that Java 8 is going to be around a lot longer than 2023. But I got a bit of a surprise about that recently, which I'll show you in a second. So what else goes on in Java 8 and 11? Well, it's kind of housekeeping. There are some things which have to happen. Things like TLS 1.3 support. TLS 1.1 is definitely dead now. TLS 1.2 is expected to be broken within the lifetime of Java 8. So if you don't backport TLS 1.3 support, you have a problem, because it means that the existing VMs can't be upgraded to a secure state in, let's say, 5 years' time. So sometimes you do have to do some work to bring features and bring small things back into Java 8 just to keep it safe and secure and current. Another one was Xcode 10 support for Mac, because until very recently, the only way to build Java 8 was to keep around an ancient Mac from like 10 years ago with a really, really old version of Xcode on it and disconnect it from the internet so it didn't try to update itself to allow you to build OpenJDK on Mac. And that's obviously not sustainable. So you have to make changes to the Java 8 build scripts for Mac to allow it to build with a modern Xcode. But beyond those types of housekeeping activities, there's not a lot of backporting going on. It's really only security stuff. It's very small features, including JFR, which we'll talk about later. Okay, so that's where we are. We now live in a world where Oracle has declining market share. Lots of other vendors are also producing Java binaries, and Java has evolved into a brand a bit like Linux, where you have distributions of Java in much the same way as you have distributions of Linux. That's the key point to take away from all of that. And with that, we'll move to the next section. So I just to put in a couple of slides about New Relic. I don't know how much developers are aware of New Relic. Once upon a time, it was the new hotness, but no one stays the new hotness forever. So for people who don't know about New Relic, I'll just say a couple of things. It's performance monitoring. We like to use the term observability these days because it goes beyond just performance analysis with your infrastructure and lots of other things as well. We have a lot of customers and a lot of data. We handle billions of events per minute. So we have the ability to take in a vast fire hose of data from all of our customers. We have this thing called New Relic One, which is an observability platform, which is really cool, which I'm not going to talk about. The other thing which is kind of interesting is that since I've been there about 2 years, one of the things that I've done is help guide the company on a journey to open source a vast amount of code. So last year, one of my big projects was guide the company through open sourcing about $700 million worth of intellectual property, which was an interesting journey. But when we can travel again, you can buy me a pint in a pub, and I will tell you that story. What else? Well, for our services and the things we build internally for our own use, Java is the majority of it. We have one of the biggest Kafka installations in the world. Confluent, I don't think they have a clear ranking of what the biggest install looks like, but we're certainly up there. And a lot of our services that aren't written in Java are instead written in Kotlin. So that gives you some idea of our tech stack. The overall architecture looks like this. And this, so what we do is we write a piece of code. We're talking with this Java user group, so let's just pretend that's a Java agent. Instead, in the sense of Java Lang instrumentation. There's that package. If you look at that, you'll find that there is a way to write a piece of code which will execute before the main method of your application. So what's called a pre-main. And the agent pre-main allows you to set up and the ability to do instrumentation and monitoring inside a customer's application with no foreknowledge of what's there at all. It's quite a neat trick. I probably don't have time to talk about it or show you any examples, but there are ways of doing it. And you end up doing kind of bytecode manipulation and all kinds of low-level hackery in order to weave instrumentation throughout the target application. We then, from that, we can generate data. So we send up data over HTTPS into what we call our core data pipeline. And so everything inside the pale blue box is hosted in a New Relic data center or increasingly in AWS. And our core data pipeline takes the data from customers, not just Java customers, all of the other languages we support, all of the other data sources we might have, chops it up, puts the data into Kafka. We have this special cool database called NRDB, which is kind of interesting because it's a database designed specifically for telemetry information. And then we put it through microservices and produce dashboards, and people can see them. So the point about this is, when I talk about data and data coming from our customer pool, it is live data. It talks about the exact state of our customers' VMs. So customers are have the ability to opt out of this type of data collection. So we only aggregate data from people who have consented to it. It's very important. We take our customers' data extremely seriously. But the graphs I'm about to show you are just that. They are live data from the genuine, real production state of our customers' machines. So it's not like people can fill in a survey and lie on the survey about what they're actually using in production. We get our data from the machines, not from the humans, and so it's absolutely accurate. Well, it has biases. Everything has biases, but it's come purely from the production state of the machines. So this is what I'm going to talk about in the next section. We're going to talk about the trends in the shape of the market, which versions do people use, which vendors do people use. So this is accurately reported from customers' VMs. And to give you the idea of the size of our data set, the analysts' estimates, I can't remember exactly which analyst it was, and I think it was probably Gartner, but I need to actually confirm that. I'd hope to actually get an answer about that one before this talk. But anyway, so our standard analyst estimate is this is roughly 1% of all Java VMs, I should say Java SE VMs worldwide. Doesn't include Android, it doesn't include Java ME, of which there's a surprising amount more of still left in the world than you might think, but that's another story. So 1% of all Java SE VMs worldwide. So it's not everything, and obviously New Relic customers are not a perfect proxy for the market. Yeah, there's all kinds of systematic bias and all kinds of things in there. We're obviously only talking really about commercial companies. We're talking probably overrepresented in the enterprises and underrepresented in startups. So there are definitely biases in here, but still, it's a big data set. A 1% sampling, even if it's a biased sampling, should hopefully tell us something. So let's take a look with the first big question. Which versions are people running? Here we go. This is actually from a few weeks ago, but that gives you some idea. So we have 62.43% running Java 8, 35% are running Java 11, and everything else is a rounding error. So, and this is why I kind of say that there is the LTS and there's everything else. So between them, the LTS versions are 98%. There's less than 2% on all of the non-long-term support releases combined. So which is pretty impressive. Like I said, this was from a few weeks ago. So just before this call, I actually inserted a new slide. So this is live data as of this morning, because I thought it might be fun to have some trend information. So this is what's happened over time. You see, we've had the Java trend has drifted up and down. So this goes back to kind of last summer. So last summer it was still, Java 8 was still roughly about 70%. But since then you can see it's narrowing, and that if you follow along with the dotted line, it's actually closing in on 50-50, and it's moved significantly in the last few months. So I don't know what has caused this sudden bend in those lines, which has come about since February. I would like to say that that's kind of the point at which I started giving talking about this and showing some of this data, and I've clearly energized the market in such a way that that's obviously not true. It's just pure correlation. So that's kind of interesting. And the trend in containers is kind of even more pronounced. So that's our starting point, is that we are heading towards parity. I made a bet a few weeks ago, not exactly a bet, I don't really bet, but a prediction, let's say, that we would see 50-50 before September, before the release of Java 17, that we'd see parity between Java 8 and Java 11. And I feel pretty secure in that prediction now. I don't think that I've seen anything which is going to cause me to deviate from that. Okay, so that's our trend information, looking pretty positive. It's taken a while. Java 11 was, I think, a much more of a slow burn release than Java 8 was. Because when Java 8 came out, everybody wanted Lambda expressions. So it was no surprise just how quickly that got taken up. But Java 11, it's taken, well, it's It's going to be 3 years in September. So it's taken 2.5 years to get to this point, which is not great, but I think people are finally, hopefully, getting the message. So what else? Well, I've said that vendors are, the vendor market is changing, and that's actually very true. Here we have a breakdown of the Java market by vendor. Oracle are, as you can see, still the largest single vendor, but they are less than half the market now. They're 42%, which I thought was quite interesting. I should also say that this pie chart is kind of not entirely accurate either, because looking at the data, there are some vendors who ship a JVM, but they don't change the vendor and version string and the hotspot identification string as well as they might. So this is an overestimate. Some of the VMs that we're marking as Oracle Corporation here actually come from other vendors who don't change the version string. So I'm working on ways to get more accurate data, but this almost certainly overestimates Oracle's market share. I don't know by how much yet. Even so, that's pretty dramatic, because their decision to stop producing free supported versions of Java 8 was only 2 years ago. So in 2 years, they've gone from about an 80% market share to at most 40%, which is a hugely significant drop-off. When we break it down by version, so now we're faceting by not only the vendor, but also by the what version of Java that we're talking about. It gets even more interesting. The vast majority of Oracle's market share actually is Java 8. And in fact, Adopt OpenJDK is the largest supplier of Java 11 runtimes by quite some way. Adopt OpenJDK is, you can look at the numbers, it's about 150% the size of Oracle's Java 11 market share, which is, I was quite surprised by. So for Java 11 and upwards, Adopt actually has bigger market share than Oracle, which is kind of a bit of an unexpected result. I wasn't expecting that when I did the analysis for this. Okay, so that's interesting. That's the kind of thing that developers love to talk about and theorize about over beer where appropriate. But we wanted to talk about containers. So let's move on and talk about containers. And these are some of the results we have for how many of our JVMs that our customers have are in containers. So yeah, it's around about 63%. And that number, by the way, is trending upwards quite healthily. And of those versions,
does that include, like, is that both like on-prem and cloud, like all your installations for new Relic, all your new Relic customers?
So in general, we can't necessarily spot the difference between a containerized VM that happens to be running on bare metal and the ones that are running in cloud. Okay. We are looking at ways to identify cloud-specific ones, but there are some complexities with that, because trying to do things like dynamic tracking of which IP block it came from is somewhat tricky.
Yeah, no, that's fair enough. No, that's cool. So it's the whole gamut, basically. Yeah,
and what we are seeing is that a lot of those containerized VMs are actually running in Kubernetes. But yeah, this is everything. And the other thing to remember, of course, is that this also covers all of our customers, which includes some pretty large enterprises, people who still definitely run their own data centers. But that number 63%, I think, is actually pretty healthy, and it's only going up each month. The trend information, which I don't have a slide for, but the trend information for containerization, I think, has been quite eye-opening.
Nice.
Okay, so let's go to the next slide. So what about the CPU and memory in use? This is sort of interesting. By far and away, the most common CPU configuration is one CPU. And it's at this point that we start to run into some of the problems and start to get to some of the real meat of the talk. One CPU is a very bad configuration for a JVM. I'll explain why in more detail later, but think about things like garbage collection. Yeah, garbage collection is not going to be very happy running with a single CPU. So it's good that you then have 2, and then 8 and 4, but the drop off from 1 to 2 CPUs is huge. It's huge. And then the other question you might ask is, how much memory are people giving their containers? So what we're really talking about here is the container sizing, both in terms of number of CPUs and in terms of memory. And again, the eye-opening thing, 2 eye-opening things for me are that, first of all, people run with 1 gig or less. And that's 40%. That's over 40% of the containers we see are running these tiny, tiny JVMs. And that's not what I was expecting people to have at all. And then the next surprise is that something like 27, 28% of people don't set their container memory limit at all. Now that is just a recipe for getting an out of memory error. Because if you haven't set that and you haven't set XMX, it will try to grow up to what it sees the physical limit to be. And of course, that physical limit is going to be a hard stop. So about 27% of people are just apparently happy to play Russian roulette with their production containers and randomly risk blowing them up, which I was just shocked by. And again, what are people running which requires so little memory? I mean, most of the services I need, 2 gig is kind of the minimum that I would expect to run it in. But maybe they're right. Maybe actually what we're seeing is the fact that JVM services can be run in smaller memory footprint. Who knows? Okay, some other details here. The 72% of people who do set XMX is also, to that you actually have to add people who now set XX max RAM percentage, which is actually the better thing to do in a container. In a container, max RAM percentage is a better switch to set than XMX. But unfortunately, only 8.47% of people are doing it. So actually, the not set is kind of, it's a bit less than that. It's only about 20%. Only 20% of people are prepared to risk crashing their containers. Okay. The next one, which also completely surprised me, is explicit configuration of GC threads, and that's also something which most of these containers would need to do, is to explicitly say how many CPU threads are going to be devoted to concurrent collection, and in the event of a stop the world, how many threads do you want to use for that? So the difference here, maybe I should just do 2 seconds on this. The default garbage collector between Java 8 and Java 11 changes. The default collector for Java 8 is parallel, which means that it's a stop the world collector. No garbage collection work happens while your application threads are running. When you hit a garbage collection event, all your application threads stop and they're replaced by the same number of GC threads as there are CPUs. So it's like a square wave. You do application work in this phase, okay, and then you stop, and then you flip into a GC phase, and all of your CPU is taken up with GC until it's all done, and then you flip back to application mode. So you have this kind of step function with the parallel collector. With Java 11, you have this collector called G1, and what that's about is you embrace the chaos. You never ever get back to a perfect state of tidiness ever again. With parallel, when your GC phase finishes, your heap is immaculate. It is in a perfect state. But G1, you never reach that state again. It's like you going around your house making mess, but you've got somebody coming who's tidying up behind you as you go. Right? The house is never going to be perfectly tidy ever again. But as long as you're not making mess faster than the other person can clean it up, it's fine. And you can go on like that indefinitely, providing your mess making doesn't outstrip the rate of tidy up. But what's important to notice about that is that that model for G1, it relies upon 2 CPUs because the activities have to happen at the same time. It's what's called a concurrent garbage collector. So that model that I just said, where you have a group of threads making mess, creating objects, mutating the heap, and another group of threads that are doing cleanup behind them, it doesn't work if you only have 1 CPU. So if you configure a single CPU, you will get the serial collector, which is effectively the parallel view of the world, but with only 1 thread. So that's kind of important because what it means is that people think they're getting this nice concurrent mode for garbage collection, but in a single container, single core container, you aren't. You're getting something else, something you didn't expect. So one calculation I haven't done, which I think would be really interesting, is how many containers are misconfigured in the sense of what people think they're getting versus what they're actually getting. And the explicit configuration of GC threads is a good proxy for that, as is this thing, which is about who actively selects a GC. So what we have is what people have asked for, and on the right is what they're actually getting. So 68% of people do not configure a garbage collector. So what that means is, in theory, they would get on Java 8 parallel, and on Java 11, they would get G1. Now, what actually happens is that you don't notice how on the right-hand side, we've got the serial segment, which is the purple one. Doesn't appear on the left-hand side at all, but it's what actually happens. So what happens is that in 21% of cases, people end up with the horrible serial garbage collector when they didn't ask for it, but that's what's happened to it anyway. So this I think is quite interesting. Yeah, Con.
Yeah, does the JVM give you a warning if you have less than 1 CPU and you actively select G1, or should it?
It doesn't give you any kind of warning at all. The only thing which you can do, and I know some groups who do this, is if you use the flag print flags final, it will spew out hundreds of lines of log message at startup, which shows you precisely what flags you asked for and what you actually got.
Yeah, that might be
one of.
Sorry, go.
Yeah, that might be a good thing to do to switch it on. Well, you'd have to promote it to production to see what you actually got for production values, but turning that on as an exercise just to make sure that you're getting the collector and the heap sizes and all of those kind of things that you think you are. Mm. It's a bit tricky to actually look through it, but it does give you accurate examples of what you actually ended up with.
Yeah, because I guess I'm wondering in either Kubernetes environment or where people have got puppetized configs for a default container with a default number of CPU cores attached, and so they're not actively defining them in the JVM, but when they're running it as a developer on their machine, their Docker containers giving them whatever as many cores as it's configured to do so, but maybe in production, or on the servers, they're just one, and they don't realize that it's just one. That the admins made a decision for them.
Yeah, that's totally a thing that can happen. I've actually seen that use case. That's actually how we got to start thinking about some of this, as we saw some of our own services deployed through our continuous delivery, and our continuous delivery defaulted to a single CPU. And so some people who weren't setting the CPU value and overriding the default were just picking up the default config, which was one. So completely. So if you do have those kind of Kubernetes auto deployers, or funny story, I don't mind sharing this one, but at New Relic we were very, very early to container orchestration. So early, in fact, that we picked the wrong one. So we were an Apache Mesos shop until very, very recently. But yeah, so it was actually a Mesos default config of one CPU rather than Kubernetes, but the same principle applies.
Yeah, nice.
Okay, cool. All right, so that's the data. That's kind of the data heavy section. And we started to hear some of the glimpses of things like sizing your containers correctly, not assuming that the configuration that you actually set is the one that you're actually going to get. So let's talk about why 11 is better than containers. And I think there are three main reasons, and I hope this is going to be something which hopefully everyone can agree with. The three biggest reasons for choosing 11 in containers are var, modules, and the HTTP2 support. I'm joking, of course. There's no benefit in containers to essentially any of those things. Well, arguably HTTP2, I suppose, but no, they're just. I guess I put this slide in because I've seen so many talks about where people talk about, hey, come upgrade to Java 11. It's great, you get var, or you get modules, and I'm just like, okay, that's not actually a good reason for most developers. So it's just me poking fun at them. What are my real reasons for using 11 in containers? Well, I would say that there are really four things that that ordinary developers are going to get out of this. The first thing is container aware. And I'll explain what that means, but you can broadly guess. It essentially means that providing you pick sensible defaults, i.e. not one CPU, the Java 11 will do the right thing. It will set itself up and it will kind of auto-configure itself in containers much better than 8 will. 8 was never designed with containers in mind. And some of that support has been backported, some of it hasn't. We're going to talk about G1, GC a little bit as well. And related to that and memory, there's also compact strings and heap reduction, which is another topic which lots of developers aren't aware of, but is actually really handy. And then finally, we've got a whole section about JFR later as well. So if you're actually going to be accurate about what you get in production, you have to reason and think about things like which GC algorithm am I going to get.
Are you changing slides? Because we can only see who actually selects a GC. Slides are not changing on our end, I think.
That's weird. So was this the last slide that people saw?
Yeah, who actively selects a GC? Yeah.
Okay, let me start and reshare again.
I think that's why the joke didn't get too many laughs. We didn't actually see it.
Oh, that's terrible.
We'll give you a laugh this time.
That's okay. Okay, so can you see the why is 11 better in containers slide?
No, there's no
Black screen.
Okay, that's annoying. Can somebody else take the screen share? I have seen this before from time to time, that actually if this happens, if someone else takes the screen share and then I take it back. Now, see you there, can you take it?
Okay, cool. So I'm gonna share my screen and then you're gonna take it back. Is that what you're trying to say?
Yep.
Okay. I'm gonna share this one. Okay. Yeah, maybe you can take it back.
So let's. Okay, and now if you drop it, because I can't take it from you because you're. So if you now stop sharing, I can try again.
Yep. 1 second.
I hope this works because the only other thing that I can do is to actually drop from Zoom and come back again.
How do I stop my share? I can't.
It's on the Zoom window.
Yeah. Should I close this one?
There should be a little floating dialog boxy thing.
Sorry.
And I'll have another window should have popped up somewhere that has stop share on it.
Should I close the meeting controls? Is that what you're trying to say, Quan?
I was going to, yeah. I mean, look, just try quitting Slack because that might actually just force it to stop sharing because you're just sharing Slack. So
yeah,
if you quit Slack, then that'll probably be the quickest way out. Yeah.
Okay. Sorry, I don't know.
Still got it.
it's still there. The last view of the window is still there.
I don't want as much. There you go. I saw it. Stop share. It's a print at the top.
Okay.
Okay.
Right. Let me try again.
Okay.
Okay. Can we see like my
Yeah, we can
background?
now.
Yeah.
Okay.
Yep.
Let's try this. All right. So why is Lemon better than containers? It's these things. Excellent. Thank you, Matt. I'm kidding. It's these things. It's container aware, a better version of G1, and JFR, which we'll talk about later. Yay. So if we're actually going to be accurate about what we see in production, and this is what container aware really means, is you need to think about which GC algorithm, how it's going to get selected, memory usage, making sure you don't hit the top of the container and crashing out from that, and CPU usage. And so a key question, this is kind of the hook that you can hang it off, is if you call the method in your Java program runtime.getAvailable processors, what does that return? And that, answering that, from your laptop, it's going to return, whether if you have hyperthreading switched on, it will return physical CPUs times hyperthreads. Otherwise, it will return that. If you return it inside a Docker container, what does it return then? Does anyone know what the answer is?
Depending on the Java version, probably. Like
it is exactly depending upon the Java version, which is not an answer you actually want. That's a terrible thing to have happen. It's a failing, I would say, in the Java environment that we, firstly, that's the answer, and secondly, that it's not really well documented that can happen. So how is a GC version selected? Well, it depends on this thing called GC ergonomics, which again is not very well defined. But broadly, it depends upon the Java version. Again, not great. The determination of the server or client class, and that's like old school Java. I remember back in the Java 4 and Java 5 days where you had switches called -server and -client, and they forced a particular mode for the JVM. They actually refer to which JIT is also in play as well. But they are very, very old ways of thinking about how the JVM should run, and yet they still play a role in terms of which GC is selected, and CPU count, of course. For those of you who aren't scared of a little bit of C++ code, this is actually in the OpenJDK source. This is the actual code which determines what GC you select, and you can see clearly it says select GC ergonomically, which is kind of scary. Okay, so max heap size. This is another one, and you see, this is the print flags final that we were talking about earlier. So yeah, if you just do print flags final minus version and pipe it through grep, you get one of these output sizes like this, and this is the format of it. On the extreme left of the output line is the type, which is like a completely raw, unadorned C++ type. So that's a size underscore t called max heap size, and the value of it is this value here, which is, to save you doing the maths, it's 4 gigabytes. So this is run on a 16 gig laptop, and then a couple of other bits of metadata about the switch as well. Well, as promised, in a container, it depends. So if you run max heap size, if you're before Java 8 update 191, which was only about, 18 months ago, you cannot see the container. So if you're running something inside, let's say a container on a physical host with 128 gigabytes, you will see 128 gig. So your max heap size will be 32 gig. Yeah, real shame if you're running in an 8 gig container, isn't it? And you haven't set XMX, because that means your heap will just grow and grow and grow. It will hit the 8 gig limit, which is the actual container size, and you will be shot down. So the container will crash if you are running on an older version of Java 8. 8U191 does some fudging to kind of make it work slightly better. But the actual real solution to this problem is upgrade to Java 11. Right? That's essentially the punchline for all of the things I'm going to tell you about in this section. I'm afraid there is only one solution really to all of this, and it really is just to upgrade to 11. So the memory in the container consists of the heap memory. It contains off heap, which is metaspace, JFR data, bookkeeping. But it also, remember that your container may contain auxiliary processes. Not every container only runs a single process. Many of them do, some of them don't. You also need to account for the memory for those things as well. And as we said earlier, roughly 20% of containers are in the situation where they are risking a possible out of memory error. CPU utilization is even more complicated. So prior to 8U131, again, it does not see the container at all. Then there is a couple of fudges which are put in after that. But the problem here is things like how many GC threads do you have? Now remember, if you're running on a physical host, which is huge, 128 gig of RAM, 64 cores, and I'm running in a 2-core container. Well, if my JVM is too old, the number of physical threads that we saw will be 64. So, okay, it's Java 8. It's a very old version of Java 8. It's running in a 2-core container. How many GC threads am I going to get? Well, I'm going to get the same as the number of actual physical cores on the machine, because my JVM is not correctly reporting the C groups. So that means 64 GC threads. Now, how well do you think that's going to perform when there are 64 GC threads contending for 2 CPUs during a garbage collection? Now, the answer is not very well at all. So your performance will be crippled because you can't see the container, and so you're generating way too many GC threads. It's these types of problems that we're talking about. You know, the VM managed thread pools, which also crop up in other places in the VM. So this is why it's a very useful thing to do, to explicitly set the flags to size these things correctly. Related to this, of course, is the new version of G1. I've got an entire thread about an entire deck about Java 11 presented with cats. So this is the G1 slide. And I just realized there's actually a terrifying plastic cockroach as part of the set dressing here. And that's, hadn't seen that before on this slide, which is just frightening for this time of the morning. So what is G1? It's garbage first. It's very much improved. The version in 11 is so much better than the version in 8. It's kind of funny. I always like telling the story. It was originally intended to be a low pause collector, i.e. a replacement for concurrent mark and sweep. Instead, it's ended up as a general purpose collector. So it's kind of strange. It started off to be this like high performance, we're never going to pause for very long. And instead it's totally gone in a different direction. And it's ended up as kind of the everyday corrector. It's actually very good these days. Its design aims basically are it's scalable to larger heaps. You know, remember when we were talking about parallel versus G1, where parallel is like all the application threads, none of the application threads, but all of the GC threads, and that kind of choppy square wave behavior. One of the things about that is that parallel is all or nothing. You can't stop a parallel collection partway through and say, oh, that's enough GC for now. I've got work to do. I'll come back and finish the GC later. It's not how it works. Once you start GC, you have to finish it. And so what that means is that the GC times for parallel are linear in the size of the heap. So the bigger the heap is, if you have a 20 gig heap, it's roughly 10x the pause time of a 2 gig heap. G1 is designed not to have that problem. G1's trade-off is it may cost a bit more CPU, but we want the ability to do some GC work and stop and restart the application threads and then do a bit more GC later on, which is that tidying up behind you as you go kind of property that I was talking about. Because the idea is to control the pause time, providing, of course, that you're not making more mess than you can actually clean up. So this is the way that you would kind of describe the G1 collector. It is a parallel collector, uses multiple threads. It's concurrent because it works at the same time as your application threads. But notice you can only be concurrent if you have 2 CPUs. If you only have 1 CPU, you cannot be concurrent. There are some other words as well there, which kind of you might have heard of in regards to GC. What's different about it is it uses regions. So you can use, this is how we are able to do the partially clean and restart app threads. So it's still generational. You still have young and old and those types of words to describe parts of the heap. But instead of in the old world where you had like big slabs of memory, like there's young generation, there's old generation. Instead, for G1, the heap looks much more like this. So all of the regions are kind of mixed up and jumbled together. And individual bits of memory, individual regions here can change role. So the same physical range of memory can be one role in one part of the application's lifetime. And later on, it can change and say, well, I used to be an Eden region, which is where the young objects are generated. But now I'm going to be an old or a tenured region instead. I'm going to skip the parts about G1. So effectively, the bad news about G1 is that it's not very low pause, actually. Its default pause goal is 200 milliseconds, which is actually pretty easy to achieve. But trying to get G1 to reliably do GC work with a less than 50 millisecond guaranteed pause is not very easy. Good news is things are better in 11. So in 11, the algorithm has been changed quite a lot, and a lot of tweaking and a lot of feedback based on production information, and it's significantly different. So one of my other pieces of advice is, and you can tell what the punchline is going to be. The punchline is going to be, you should upgrade to Java 11. If you are running a Java 8 application with the G1 collector, you should upgrade to Java 11. Because the version of the algorithm and just the behavior of the GC is just so much better. Of all of the things that I've upgraded at New Relic to 11, which is quite a lot now, I have never seen an application that was running G1 on 8 that did not do noticeably better on Java 11 once it was upgraded. Related to this is complex strings. So this is, again, this is not a cat pictures. This is kind of an interesting one. People probably know that, if you remember the first time you ever learned Java, people introduced primitive types to you, and you're like, ints are 4 bytes, longs are 8 bytes, blah blah blah, right? Everyone remembers a char is 2 bytes. Yeah, which is a surprise if you're a C++ programmer. If you come from any sort of low-level language like C, you think a char is like 8 bytes, is like one byte, 8 bits. So where do these 16-bit chars come from? Well, it comes from the fact that it's actually Unicode. It's actually UTF-16, which is fixed width for virtually everything you're going to encounter. It's not actually fixed width, but that's another story. The thing is, though, that a lot of what we do actually manipulates chars which come from Western European languages, kind of ASCII or Latin 1 in this case. And what that means is the first byte's always 0. So we are wasting 50% of the string storage, because a string is a metadata object which has a reference to a char array, which stores the actual chars of the string. So if we're storing an ASCII string, we're wasting just under 50% of the total size of the object. And depending on what you're doing, lots and lots of people's heaps are mostly strings. So if the first byte is always 0, can't we do something smarter? Yes, we can. So from Java 9 onwards, you have a per string choice. When every time you create a string object, you actually decide whether or not this is a genuine Unicode string, and if you're writing Russian or dealing with kanji or something like that, then you will still get a UTF-16 string. But in a fairly common case where it's just Western European strings, you will get a Latin 1 string. And the representation of that is in bytes. So it saves all of those 0 bytes. And if you look at the source code of Java lang string in Java 11, then you will see this code in here, and you see the value field, which in Java 8 is a char array, is now a byte array. So this, if you have big heaps with lots of strings in them, The way that you would get some quite useful free performance, and I'm talking 30 to 40% reduction in heap size, just from upgrading to Java 11. Because you don't have to do anything, you don't have to recompile. This is purely about the runtime representation of the string in the heap. So we've seen dramatic decreases in the heap size just from upgrading to 11. Okay, so now let's talk about Java Flight Recorder. How am I doing for time, by the way? I see we've been on for about just over an hour.
Yeah, so how many minutes do you need? So maybe we can.
I mean, like another, I could do like another 5 minutes. We can just talk about JFR quickly and then like questions if there are any. Yeah?
Sure, that's all right. Okay, cool.
So JDK Flight Recorder, I keep calling it Java Flight Recorder, as lots of people do. I'm reliably informed by my buddy Marcus Hurt that actually it should be JDK Flight Recorder because you can't use the Java trademark. Okay, so JDK Flight Recorder. This is a profiling tool. It gathers diagnostics and information about a running Java application. It's kind of funny because when it was part of Oracle, it was called Java Flight Recorder before becoming JDK Flight Recorder when open sourced. But the J didn't originally stand for Java. So now it stands for JDK. It used to stand for Java. It used to stand for something else before that. It used to stand for JRocket because that's how long this thing has been around. It's a proprietary tool which dates back all the way, or originally proprietary tool, which dates back all the way to BEA systems. So the first major Java application that Oracle did before they acquired Sun, that's where the tool came from. And then when Java 7 came out, they ported it over from JRocket to start working with Hotspot and used to sell it as an additional tool. It's open source as Java 11. It has been backported as of about 9 months ago to Java 8. So this is one of the things that you can use without upgrading to 11, but you should still upgrade to 11 anyway. It's a really nice piece of kit. So Oracle claimed that it does about 1% impact to steady state performance. From what we've seen at New Relic, we observed that it's about 3% on a useful data profile. Out of the box, it comes with a GUI console, and you use it like this. You can start it from the command line and generate an output file. But the problem with that is that's kind of challenging in containers because this thing is designed to generate a dump file. Okay, how do you get the dump file off? How do you make sure you actually retrieve the dump file before the container disappears? Because you kind of want the dump file if the container is about to go away, because it may show you why it crashed. And if the containers are ephemeral, once that's gone, it's gone. And that was kind of the information you wanted. So there was a real kind of mismatch between Java Flight Recorder file version and everything else. Now, the good news is there's a streaming solution. But the bad news is it only shows up in Java 14, and that's not LTS. And you've seen how few people actually use that version of Java. So until Java 17 becomes mainstream, streaming Java Flight Recorder is not going to be a thing. So it's unfortunate. So what else can you do? Well, we can use the J command to basically start and stop, create recordings, and dump them. Spoiler for the next section. This functionality is also exposed over JMX. So if your Java application is running JMX, you can spin up dynamically a JFR recording and start recording it. You can also get the file back over a network socket. And that's the point where the JFR technology starts to get really, really interesting, or at least that's the point where I started to get really interested in it. Because then you can start taking files directly off the box, you can aggregate them, you can do all of this automatically without requiring manual controls or startup flags. So here's the mission control dashboard, is what it looks like. And you can see, I mean, you can probably tell for those of you who've used the Eclipse IDE, then this widget set probably looks really familiar. And sure enough, mission control, JMC, is built on top of the Eclipse widget set. And it's a great desktop tool. If you have a dump file from a JVM that crashed or one that you're doing some performance analysis on, you can use mission control to go very deeply into it. It's got a lot of great data, and you can step through it. You can look at things like allocation. So this is a test application which is allocating 10 gigabytes of memory per second, which is kind of interesting. And then you can do method profiling. You can see what are your hot methods and all the sort of things that you might want to have. The problem is this is a single file and from a single JVM. It's not the kind of thing which you can use for monitoring or for observability. So there are some things you can do. You can use jcommand to dump the file. You can SSH in, but it's not DevOps Pro. So to finish with, I just want to show you what we built, because I spent some time building a product called real-time profiling for Java. It's an open source code base. You do not have to use this with New Relic. You can check it out. It's on GitHub. I need to update the slide because version 1.2 is now out. But if you do want to use it with New Relic, you can sign up as well. So you can actually use it to see this kind of view. This is what our Cluster Explorer looks like. So there's a whole bunch of VMs down the left-hand side. This is the last couple hours of the cluster. And you can see that the grayed out ones are the ones where the machine's okay.
I think.
And then a couple of levels of warning.
Slides have stopped again.
Yeah.
Oh, Zoom, the bane of my life. Okay, so let's try this. I've got like a total of like 5 slides left. So let me. Does someone else want to grab control again?
Hold on,
Can you grab control?
Let me just.
Yeah. Okay, and let me. How's that? Can you see that okay?
Yeah.
Yep. Okay, excellent. Right. I'll race through these last few slides just so that we can get to the end. Okay, so this is a cluster view. The darker the color, it's kind of like traffic lights, the worst condition the machine is in. But you can also go backwards in time and see what the state of the machine was. So if you, for example, an outage is happening, you can look at the good state of a machine before the outage happened. And this is what the view that you get in New Relic looks like. You've got flame graph at the top, metric usage, CPU, thread usage, network traffic, all your kind of telemetry information has come straight out of the JFR data. And it's not shown on the screenshot, but you can even do like deep dives, so you can tell which of your threads is allocating. So these are some of the allocation graphs. So it's a key piece of the ecosystem. It's not all of it. It's part of the pivot that I think is happening industry-wide towards open instrumentation. And I think it's really important that Java maintains this kind of first-class status. Lots of the things that are happening in the open instrumentation and the open telemetry world, it's very kind of Go focused. And I think it would be quite easy for Java to kind of get lost in the mix there, because it is a language and environment which very much builds on top of, well, it's kind of middle-aged now as programming languages go, Java. It comes from an era of bare metal and virtual machines, and it takes some thought and some care to make sure it makes the transition into the cloud native world as well as other languages and other environments do. And part of that is ensuring that things like OpenTelemetry and open instrumentation, that we're able to monitor and observe Java applications as well as we can other languages as well. So that's essentially what I'm doing at the moment, is trying to make sure that we do as much as we can to make sure that Java has this first-class support. Finally, just because someone asked me about it, there are also other frontiers. It's not just observability. Things like GraalVM native and Quarkus and J-linked binaries. Because the other challenge that you have with running Java in containers is startup time. And that is an area where these technologies are also starting to make progress. Just this week, Eclipse Adoptium have started an incubator project to look at fast startup, effectively saving the output of the JIT compiler, so that on other runs, you can actually have preloaded JIT optimization so that you don't need to warm up. Very early days, but this is the other frontier that I think is really important for Java. Okay, so conclusions. Upgrade to 11, size your container correctly, don't use single core containers, choose your memory and GC flags, make sure you have single core containers for several reasons, but most of all, that you need a concurrent GC. Yeah, Java 11 is designed for use for the concurrent GC. Make sure that your containers support it and enable JFR. And yeah, books were mentioned earlier on. Optimizing Java has been out for a little while, but I think it's still good. And I'm working on a new edition of the Well-Grounded Java Developer, my very first book. So thank you very much. Any questions?
Thanks, Ben. Just quick one. In the previous slides, you talked about JIT profiles. Who was doing it? Was it Eclipse Foundation or?
Yeah, so the Eclipse Adoptium, which is the new home for Adopt OpenJDK.
Okay.
And the folks that are involved with that are Alibaba and Google, I think, are planning to contribute, and New Relic are planning to help with the testing. I don't know that we'll make any code contributions, but we'll certainly help out with testing, because we've got this nice CI/CD environment, and our teams are very interested in the problem of fast startup.
And that would be open source, right? I mean, free.
Oh, absolutely. Yeah, yeah.
Because I know that I think Azure, they have the same. I mean, they used to have, at least, not sure about now. They used to also have the JIT profiles, and then that for fast startup times. But that was in the paid JVMs, I think.
Yes, absolutely. So this, everything which happens at Eclipse is open source.
Yeah. Okay.
So this will be open source as well.
And on one of the diagrams that you showed regarding the versions on Java, do you have like exact versions of Java? Because it would be interesting to see, like, after like 191, I think, where it was backported, the container support and everything.
Yes. And the answer here is yes, I do have that data, and unfortunately, no, I can't show it to people. The problem is that we have to balance providing too accurate information that might be useful to attackers. If I publish something which has exact version numbers, a black hat can look at that and reverse it to CVE lists, and then they've got a shopping list of attacks to try. So we don't show the fine-grained data.
Yeah, that's okay. Okay, yeah, thanks, man.
No worries. Any other questions?
And regarding the low footprint kind of, you mentioned Quarkus and everything. I think there's another one, Micronaut. I'm not sure if you heard about it.
Yeah, I've heard about it. I mean, there are several projects in the space. I mean, Quarkus, I think, gets a lot of attention, but I think Micronaut is another approach, because I think they do something similar to Quarkus, and they do, they use GraalVM under the hood.
Yeah, I mean, yeah, I think it could be used for like a function as a service, I believe, in cloud. So like with Micronaut and then GraalVM, and then deploy it as a function probably, and it would be much faster for fast startup and everything. Yeah,
that's certainly one of the other use cases, the kind of function as a service, AWS Lambda kind of thing. It's kind of strange. I don't know what the numbers are. This was a couple of years ago. I was talking to them, but I was talking to some of the folks at AWS, and they told me that something scary like 30% of people who run a Lambda that's written in Java pull in Spring and Hibernate. Like, that does not sound like the right use case for that.
Yeah. Okay, thanks.
So do we have any other question?
A bit of an underarm one here. Sort of appreciate the work that New Relic does and helping you do presentations like this. Does any of the kind of best practice that you've identified so far in the talk today, Ben, does New Relic sort of alert to that or provide guidance from inside the tool as to any low-hanging fruit that might be available for immediate optimizations?
Not out the box. That's kind of a philosophical question. So what you could do is you could easily configure an alert on any of the things that I've talked about here. But we don't do that for you. The New Relic is kind of an unopinionated tool. So if one of our field engineers or someone put in a support ticket to say, hey, I'm concerned about container sizing, then someone would follow up and say, oh yeah, sure, you just need to configure an alert like this, and then they would go and do it, and that would kind of be a self-serve thing. And the answer is different customers have different requirements. We would annoy somebody if we set up a default alert, even for something which is like, well, why would you ever want to not do it that way? And we don't do that. So yeah, it would be easy for people to do it, but they would have to think to do it themselves.
Yep. I guess we're running out of time. We've actually extended 30 minutes. Thank you for your patience. Thank you everyone for your patience. And of course, thank you, Ben, for also extending your time. I know it's over. We just talked about 1 hour, but it's been over an hour. So yeah, thank you so much for sharing your knowledge and sharing everything to the MelbJVM Java community. And hopefully when the world is open, we'll be able to see you in person, in flash. Yeah.
Yeah, that would be very nice.
Yes, and
Thank
for everyone, just watch out for the next schedule of our next meetup session. Yes, we will just be posting it in our meetup page. Thank you and have a good night.
Thank you, Ben. Thanks, everyone.
Thanks, everyone. Bye.
Thanks, Ben.
Bye.
Thanks, Nelsie. See
Thanks,
you,
Ben. Thanks, everyone.
Good night.